Hello everyone, and welcome to the very first topic in the SS2 physics curriculum. Now if you're seeing this video for the first time, this is our channel Oya Learn, where we discuss various educational materials across different subjects to help you get better in your classroom activities. Now we are looking at physics for SS2 students, and this is the very first topic where we will be revising something that has been taught to you in SS1. The topic itself is concept of position, distance, and displacement in relation to the XY plane. Now, this topic is important as it serves as a prerequisite into your studies of vectors, especially when it comes to resolution of vectors, amongst other things like that. When we talk about parallelogram law of vectors and the other things that we do when you resolve vectors. So this is why we're going to be looking at it. We'll revise it, learn their meaning, as well as how we represent them in physics. So in the breakdown, what we'll be looking at is we'll first study position. We'll look at the meaning of positions, and then we'll look at how position is represented in physics, especially in relation to the XY plane. Then we look at what is distance, that is, we define the term distance. And then we look at the features of distance and how it applies when you're solving problems in physics. And then finally, we look at displacement by defining it, as well as looking at the features and how we use them to solve problems in physics. Now, when it comes to distance and displacement, they have some similarities and some differences. We'll look at that as well, and then we get to understand when are you talking about distance and when are you talking about displacement. That is, how do they apply in terms of physics questions when you solve different questions from different types of examination. So I hope you're prepared for this. It's a very simple topic. We've done this before in SS1, but we'll be going a little bit deeper than what we've done before now, because now we are looking at it in relation to the XY plane. So I want you to get all your materials and get along with us as we study the concept of position, distance, and displacement. And don't forget to give us a like. And if you're not subscribed to the channel yet, I'll urge you to please do so. Just take a moment of your time, click the subscribe button, and I'll advise that you also click the notification bell icon. Now, what that does is that every time we put out a new content like this, you will always be notified. So that way you don't get to miss any of the fun academic materials I will put out here on this channel. And we'll urge you also to please share the video. Now, our goal is to reach out to as many students that need helpful content like this. So please, we can reach them with your help when you share the video. So please share the video and drop us a comment if you have any question at all on what we are doing on this topic, as well as any other thing that we'll be doing on the channel. So we'll be looking forward to your comments, and be sure that we'll respond to all of your comments. Thank you so much. Now let's dive into the concept of position, distance, and displacement. I'm very certain that you should be able to define what position is. But what we want to look at is not just to define it, but look at how it relates to the XY plane. Now, those of you that have seen the video from the SS1 first term curriculum where we discussed position, we talked about this at length. So if you haven't yet, I'll urge you to please take some time to also look at that video, as it will also give you some insight onto what we know as position in physics. Now, to those who have done that, let's just dive into the meaning of position in physics and how it is represented in the XY plane. Now, when we say position in physics, it is defined as the exact location of a point or an object in space. So that is, when you have an object or a point in space in physics, you define where it is, the exact location it is, with position. So the way you will tell where a particular object is located in physics is by defining the position. Let's put that down a bit. The position of an object is its exact location in space. Now, this doesn't quite define it to the end. There are still some things you need to add to this definition to make it all encompassing. Now, what we do is we now say that in relation or reference to a point known as origin. Now, to get the meaning of what this is, let's take, for example, since we are looking at the XY plane, let's draw what the XY plane looks like. So if you have a graph like so, now this represents the y-axis, while this represents the x-axis. Now let's pick a point. Okay, now let this be a point of object A. That is the location of object A. How do we define the location of this object A in physics? We are going to define it by the space, the distance it is from a reference point known as origin. Now the origin in this plane is this point here, right? This is our origin. So let me just indicate this here as the origin. Okay, so when you define this by the distance it is on the x-axis from the origin and the y-axis also from the origin, then you have defined the position of that object. So you see that this object can be traced to the x-axis like so, and then to the y-axis like so. Now, by telling this distance and this distance, you then give the location of object A. Now, this is why in physics, when you are defining the position of an object with reference to the xy plane, we often denote it in coordinates. So it is represented in coordinates, represented with coordinates, which is given as x, y. Now, let me explain what this means. You see, whenever you are telling the position of an object in physics, you often see it in a bracket like this, or in parentheses rather, where you have x, y. Now, x here is telling us how far is it from the origin point along the x-axis. So, we're going to have several units on this x-axis like so. Let's call this is 1, 2, 3, 4, 5, and so on. And then on the y-axis, 1, 2, 3, 4, 5, and so on like that. Okay? So when you look at this now, note that the origin, okay? Note that origin on the xy plane is denoted as 0, 0. When you write the coordinate of the origin in the xy plane is 0, 0. Now, to now tell the position of this object A, according to what we see in this diagram, we see that it is 3 units on the x-axis. So that is A is located at 3 units on the x-axis, 4 units on the y-axis. So you see, this is how we represent the position of an object with reference or in relation to the xy plane. Now, what I want you to do is look at a few graphs around you. If you don't have, you can try to trace some of them on a graph book and try to tell the location or the position of each point that you will place on that graph using this method. Don't forget, all you need to do is when you pick your point, you trace it to the x-axis and then to the y-axis. And when you are writing your coordinates, always ensure that you write x first before y. And just by doing that, you can also define the location of any object in relation to the xy plane. To further improve our knowledge on positions, let us try to show on a graph the position of an object S found to be at 6,3 and another object T at 2,5. Now, this is going to be shown on the same graph. Now, I advise that you use a graph book for this purpose. So if you have a graph book, bring it out and apply the same methods we're going to use in this video, and you too should be able to find the location of this object or show it graphically, right? Now, what you need to do is on your graph book first, draw your XY plane, okay? Now, what you do is you need a straight line with a ruler. You draw. Now, note this is your y-axis and this is your x-axis. Now you can note it in full like this as well. Now you would also need a scale that works. Now when you use the basic or typical graph that we have around us, it has enough space for you to show this by representing each unit by a centimeter, right? But when you have a smaller graph, you might need to be very creative in scaling your graph. Or if you are dealing with the position of an object where you have large numbers as the coordinates, you have to get really creative with how you scale that. Okay, you may check out videos on how to scale a graph properly in physics. There are simple tricks that work. One thing you should know is that when representing units, we use numbers such as 1, 2, and 5. Like so, we don't go in between those kind of numbers. Now, when you have chosen a proper scale, now for this one, I'm using 1 centimeter to 1 unit. Now, I'm not measuring, I'm just freehanding this. But when you use your graph, it's all measured there already. So you just have to follow the lines drawn in your graph. Now, your graph would have thick lines now which represent each centimeters. Now, along that, you're going to put the increasing units of 1. So where this is the origin 0, on the x-axis we'll then have 1, 2, 3, 4, 5. I'm trying as much as possible to make sure that they are evenly spaced. 6, 7, 8, and so on. Now, you don't have to stress yourself by ensuring this is evenly spaced in a graph book because the measurements are already there. Now, we are going to repeat the same thing on the y-axis using each centimeter to represent a singular unit. So, this would be 1, 2, 3, 4, 5, 6, and so on like that. Now, all that is left to do is now find the position of these objects S and T that we have been given their location, their coordinates. So starting with object S, we see that S is located 6 units on the x-axis and 3 units on the y-axis. Now, to do this with a graph book, you can just run through the lines that are there and you get the points easily. But when you're using a method like this, that is if you are drawing it on a plain book, you need a ruler to trace out the point. Okay? So for this, I go to point 6 and then follow a straight line upwards like this. And then I find where it intercepts with point 3 on the y-axis. Now this is point 3 on the y-axis. They intersect at this point. Now you see this point here marks the position of object S. I hope you understand how this is done now. Now let's use the same method to mark the position of object T. Now for object T, what do? We go to 2 units on the x-axis, trace that upward, yes. Now we see it intersects with this, but this is not the point we are looking for. The point we are looking for is one that intersects with 5. So we continue like so, and then we check for 5. This is 5. 5 goes like this and meets at this point. This is where they intersect. So this would be point T. Now once you have this, you can then wipe whatever is left away like this, so that you just have point T and point S. Now that you've done this, using the same graph, I would like you to mark this point. And see what it looks like on your graph. If you have any question on this, don't forget that you can always drop your questions in the comment section and we will definitely attend to all of your questions. It is important to note that objects in physics can be acted upon by a force. And when this force acts on them, it forces them to change their position from one point to another. Now, this is called movement or motion in physics. Now, when a force acts on an object and it forces it to move from a point to another, they travel something known as distance. So we have to look at what does distance mean. But this time we are looking at it in relation to the XY plane. Now, those of you who are familiar with this, we say that distance is the entire path length that an object travels. Okay? But we're going to look at it from the XY point of view. XY plane, I mean. The XY plane point of view. So let's first put down the meaning of the word distance. So we say this describes the entire path length an object travels. Now, another thing you should note is that it is always positive. You cannot have a negative distance. So whether the object turns or return back to where it's coming from, it is always positive. You're going to measure the entire path length that object travels. Now, those of you who have seen the video we did on distance for SS1 students, you recall that I mentioned that when you have distance, in a case where an object travels from one point to another and then return back, I did something like this where we say it starts at point A and then moves all the way to point B, which is, let's say, 10 meters. And then returns back. Now, this is direction here. And then it returns back to this point. Let's call this C, right? And this is, for example, let's say this is 6 meters. We say that the total distance would be 10 plus 6, which is 16 meters. I believe you recall something like this. And then we also talked about when it goes along a winding road like this, where this is point A and then point B. We're going to measure the entire length of this path is what will give you the distance that the object has traveled. And then we also say when it goes and turns along the different axes, that is, if it goes from point A like this to this point B and then all the way to point C like this. Now, if this is 4 meters and this is 3 meters, right? The distance is therefore 4 plus 3, which will give you 7 meters. So you see that in all of this case, we look at the entire path length that the object travels through. Now, what we want to look at next is to represent different positions of an object in the XY plane and see how you can measure the distance that such an object has traveled through. So follow me and let's do that. We understand what distance means, but in the XY plane, how can you measure the distance that an object has traveled? Now, this is an object S at initial position 2, 3. And then final position 5, 7. You understand that these are the coordinates of the position, right? And where 2 marks the distance on the x-axis and 3 marks the distance on the y-axis. And the same thing affects this coordinate here. 5 is the distance on the x-axis and 7 is the distance on the y-axis. Now, this object that has moved from this point here to this point could have gone in different path lengths. Okay? It could have gone on a straight line like this from this point to this point. If you're going to measure that distance there, is the entire length of this that you need to get the distance that the object has traveled through. Another way it could have gone is it could have gone this way and then gone all the way up here, where what we have here is a right angle. Now, I'm using this specifically because this is some of the kind of questions you're going to find when you're solving problems on distances, especially as it relates to the XY plane. Now, note that it is not limited to this kind of movement. It could have gone in a zigzag path. It could have gone even in a random path and then end up at this stop point here. That is this location here where you have 5, 7. But we're looking at this particular one to solve some kind of problems that you're going to face when you discuss distance in relation to the XY plane. Now, when you look at what we have here, okay, you see that on this X plane here, these objects have moved from 2. Remember, this is X1 and this is X2, right? It has moved from 2 to 5. So this is 0.2, this is 0.5. Meaning that the distance here is what? 5 minus 2, which gives you 3. Remember, we are still dealing in just units here. It could be meters, it could be kilometers, it could be anything depending on the scale of the graph you are working with. Okay? And when you consider the length of this part here now, what you're going to observe is that what we have here is 7 on the y-axis, and what you have here is, according to this, 3 on the y-axis. And to get the distance that it has traveled along the y-axis there, that would be 7 minus 3, which will give us 4 units. Okay? Now, when you see something like this and you're asked to find the distance, believing that it has gone through this path, okay, how you get the distance is to add up these two. That is, the total distance would be the sum of the entire path length that the object has traveled, and that is 3 plus 4, and this will give you 7 units. Now, in the case where this same object has gone from this point to this point straight like that without going through all these bends, you can also solve the distance of this object, right? So as long as what you are looking at is just from this point to this point, okay, the length of that point is all you need, then it's still a scalar quantity and can be considered distance. Now in this case, what you can use to solve this is to apply the Pythagorean theorem, where this becomes the hypotenuse of this right angle triangle, this would be our opposite, and this would be the adjacent side. And if you understand the Pythagorean theorem, just to refresh your mind, it is square of hypotenuse equals the square of opposite plus square of adjacent. Okay? And when we apply that, it means that this distance here, let's call that x squared, would then be opposite squared. Remember the length for the opposite side, we've solved that already here to be 4 units. So that will be 4 squared plus, now for this adjacent side, we solved that as 3 units. So that will be 3 squared. Now you see that the distance x squared would then be, what we have here would be 16 plus 9, and then x squared becomes 25. Now you know that when you're solving something like this and you find the square root of both sides, you say x therefore becomes plus or minus square root of 25, which will give you plus or minus 5 units. But I said something about distance earlier. I said distance is always positive. Don't ever forget that line. Whether you are solving on the negative x-axis or negative y-axis, your distance is always positive. So in that case, the only answer that works when you are solving for distance in this case is 5 units. That is positive 5. The only way it can be negative 5 is if you are solving for displacement, which we'll discuss very soon. So just to recap what we've done here, okay? When it comes to distance on the xy plane, what matters is the path that the object has taken. If it has gone along this path, recall that all you have to do is just add the entire length of each of those paths. That is from this point to this point, and then from this point to this point. Okay? But if it has gone straight from here to this, all you have to do is find any other mathematical method that can help you solve this length. Or if you have the actual length of each side, you can just use that. That is, in the case where maybe you move from here to here and then moves further again, and you have each of those path lengths, all you need to do is add them together. Or, as we have done here, apply the Pythagorean method to solve the distance, believing that it has gone from this point to this point. I believe now you understand how to solve for distance. And please do not forget that it is always positive. Let us now consider the displacement of an object in relation to the xy axis. Now we're going to start also by showing you 2 points on the xy plane. Okay? Now you know this is the y-axis. Okay? And this represents the x-axis. Good. Now let's say an object moves from this point to, say, this point. Now, when we're talking about distance, I did mention that this object could have moved from this start point to this finish point along different kinds of paths. It could have gone along a straight line like this. It could have gone this way and then this way. It could have gone this way and then this way. It could have gone this way, this way, this way. It could have gone along a curved path. It could have gone along a zigzag path. There are so many ways this object would have moved from this position to this position. Okay? But when you're trying to measure the displacement of this object, all you need is the start point and the finish point. And how you get to measure the displacement is by measuring the shortest straight line distance from the start point to the end point of an object. So let's write this down as the definition for displacement. Okay, so we say displacement, this refers to the shortest straight line distance covered when an object travels from one position to another. Now, the key thing about displacement is that it can be negative, because all we look at here is that the start point to the end point, it could be on the positive x-axis or the negative x-axis, just as much as it can be the positive y-axis or the negative y-axis. All you need is you look at the start point and the end point, and then you join them by the shortest possible straight line. Now, in this case, it will be this. Now, when you measure the distance from here to here, what you have there is a displacement, as long as you indicate the direction. That is, it starts here and stop here. Okay? Now, there are some cases where this object will have started here, gone to this point, and returned back to the original position. In that case, there will be no displacement at all. So that is why we are saying displacement can be positive. Now, it is positive when it moves from one point to another in the positive xy axis. It can be negative. That is when it moves to the negative xy axis. And it can be zero. That is no displacement. That is if it returns back to the original position. Now, all of these are things you have to consider when you are working with displacement. Now, let us look at how we represent displacement and how we solve for the displacement of an object in the xy plane. Now, when it comes to how you measure displacement on the xy plane, now you need to understand that displacement is often denoted using this symbol. Now, displacement of an object will be written like this, with an arrow at the top here. Now, this tells you that it's a displacement because there's an arrow on top and it's a vector quantity. And it's often given by, now remember it's on the xy plane, so we'll have x2 minus x1 squared plus y2 minus y1 squared. Now, when you follow this, you can find the displacement of an object when it's on the xy plane. So, for example, if an object moves from 1, 2 to 4, 6, find its displacement. Now, you see here that the object has moved from one position to another. And don't forget, when you write coordinates, we write x, y. Okay? So that means this is the initial position where we have x1 and this will be y1. And this will mean x2 while this means y2. Now, the displacement of this object will be solved following this equation. Displacement equals square root. Now, what we have as x2 is 4, so that will be 4, minus x1, which is 1, in bracket like this, squared, plus, now y2 is 6, minus 2, in bracket squared. Now this would mean that we would have, this would give us 3 squared plus 4 squared. Now what we have here would be, now this is 9, this is 16, which gives you 25. Now your displacement is therefore 5 units. Now when you solve like this, you get your displacement. Now there are some cases as well where you can apply other methods to find your displacement, like when you're not given the coordinates of the individual points that the object has moved from and to, right? So when you have that case, you may need to look at it using vector diagrams, which will often give you a shape. Now if you recall, there was one question we solved earlier where we had a right angle triangle and then we applied the Pythagoras theorem. You can apply that also to find the displacement of an object, especially when you are told that the object moved from one point to another and then to a new point. And then you have to join the start and end point with a straight line, which then makes the whole thing look like a right angle triangle. Now that will be another method to solve for displacement. Now there are other methods also. Now remember I told you that this is basically a precursor to what you'll be doing when you are solving on a resolution of vectors. So as we continue to solve problems on vectors like displacement, velocity and the likes, we will be using different methods to be able to get our displacement or to get our resultant velocity using mathematical method. But this is the general equation that we use when you are asked to solve the displacement of an object when it moves from one point to another. Now, I hope you understand this concept. With this, we've been able to go through the concept of position, distance, and displacement in relation to the XY plane. Now, if you do have any question on this, I would like you to put it in the comment section and we'll promise to attend to all of your comments. And please do not forget, if you are yet to be subscribed to the channel, kindly take a moment to click the subscribe button, and then you can also hit the notification bell icon so that way every time we put out a new content, you will be notified. Thank you for following the video so far. We continue with the syllabus for the SS2 physics first term work. So I'll be seeing you in the next video. Bye.